guys, so today we're going to talk about programming and communicating between a Rockwell PLC and a Festo CMMT series controller. It can be a CMMT-AS or a CMMT-ST, which is a stepper and runs the servo. And this is the layout I have here, and we're going to be using a point-to-point drives Festo EIP add-on instruction to communicate EthIP through the Rockwell PLC on the 5000 software. And the communication is Profi drive over EthIP. And we're going to be using version 20.04 specifically because that's the oldest, that way it's forward compatible. First thing we want to do is go to the internet and look at the software that we're going to look at needing and using. So I've already got a web page here, so you go to the festo.com, put in your date, your country, I mean, and in this case I'm just going to click on Canada. And we go to the support downloads area, type in the product, and we're going to look for the EP in the name, which is EthIP. Click on that. And once we've done that, we've got a couple tabs here. We've got the expert knowledge, which shows you application guides associated with the product and various third-party devices, or it gives you insight to more expert information on the hardware. In this case, we have this particular application note, which discusses a few of the Rockwell AOIs available, but not the one we're talking about today. The one we're talking about today is just about to hit the market. From a software standpoint, the stepper and the servo controller themselves, they're configured using Festo Automation Suite, and Festo Automation Suite is designed such that there's the package itself, Festo Automation Suite, and then there's plugins for each device. So if you're going to use a stepper controller, CMMT-ST, then you would put that in up here, and there would be a plugin for the stepper, whereas we're doing this one right here. So you would need to download. Scroll to the bottom of the page here. The release rate now is this one right here, 132, which is what I have installed. And these other plugins right here can all be downloaded and installed. If you don't want to download them themselves within the support portal itself, if you just download the Festo Automation Suite, install it, there is an online update feature built into the software, which I can show you later. And once you have all that installed, then we're ready to rock and roll. So the next step is to start up the software itself. So this one right here, this is my software. I'll start a copy. Unfortunately, it's starting on the other screen I have here. Okay, so we've gotten past the startup screen and the progress bar, and we're going to click on New Project, and we want a fresh download, so we come over here, we pick a device. So we can select the part number, or we can select by type code. It's going to go by type part number here, select it, add device. So we've added this. Now we want to rename it. I'm going to right click, rename. Okay, I don't like that name. I'll give it this name right here, Telegram 111 CMMT-AS linear. And then we have to do a save project. So we'll come up to here, do save as, do a browse. And I'm just going to paste it in there. So we've got a starting point, and we'll just continue. We double click on the device. And we get into here, we have a whole bunch of ORN warning counts. Well, that's because we don't have anything configured yet. That's why we have a whole bunch of warnings. So first thing to do is the first startup here. We need to configure the hardware we have. So again, same as before, you can type in the type code or the part itself. Come through here. I'm going to do a linear axis. And I'll have a 2000 working stroke. And we'll just make it 10 and apply. And then we add a mounting kit, which is user defined. I'm taking the defaults because I have no load, no anything at all loaded. So now we can hit the, let me just resize the screen a little bit here. Oh, sorry. So we've got the next button down here, so we can either hit the next button or come up to application data. I'm going to put in a minimal load here. We're going to change the voltage, which is the supply voltage. I only have 120 volts hooked up or wired. The next button, go to hardware switches. I have a normally closed contact and a normally closed contact. So I've got home switch as well as limit switches that are normally closed, which is the failsafe. And for homing method, we're going to use mode 11. The next button, software limits, those are good. The finish button. And we've got only 14 errors left. Click on that. It's going to show you what it's recommending here. I always just take the recommendations, hit apply. Anything that you have selected over here on the left, you hit apply and it'll apply these values to the actual. So hit apply. And now we have no more warnings. Save the project. The traditional shortcut keys like Control-S work. Control-O opens. Control-S saves. And device settings. Don't need to do anything there other than look at this right here. There's activation for the servo. Then we get to the Fieldbus. Then when it comes to the Fieldbus, okay, so there's two Ethernet ports on the controller. You look at any controller, there's a X18 port on the front face of the controller, same with the stepper over here. And then you have the two ports on the top, which is the X19 on this one, and it's an X1F 1 and 2 on the stepper. The top ports are for the Ethernet IP. The front ports are for the Ethernet TCP for the Festo Automation Suite programming interface. So when you're in here, this Ethernet IP interface, which you're going to put an IP address in here, that is for the top ports. And so I'm going to put a 185 over here, and if we come up to here, click on this device, I'm going to assign the front port, the X18 port. This is my device here. So that's configured. This is configured. Then we need to look at your base value velocity, accel, decel. The default seems a little low for me, so I'm just going to change this to a meter. And these ones over here to go to 5 meters. And put a higher jerk value in here. There's the factor group up here. We're not going to mess around with that yet. And most important step here is what you cannot see on the screen. You need to scroll over to here and this telegram selection. So there's 3 telegrams that offers on the EtherNet controller, and we're going to be using telegram 111, which is point-to-point positioning. This changes the whole process data memory map. So it's really important you configure that and you don't forget about that. Extended process data we won't talk about right now, but it's basically where you can map parameters to and from the controller up to 8 integers, I think it is. And that's about it right now. I think we can basically go online. So let's just go online here. We're going online to the port 192.168.1.184, and we're downloading. Well, we're gonna. That's the intention. So it says, hey, there's a whole bunch of things that are different in the controller compared to the offline, and I'm going to click on Write to Device. Once we have downloaded everything, I'm surprised we don't have any faults, but that's fine. And the first thing we want to do is store the parameter set that we just downloaded. And anytime I change anything, I like to do a restart. So I'm going to do a restart. I'll store and restart anyway, because we probably changed communication parameters and things like that, and that basically, in my mind, always needs a cycle of power. Connecting. And now we can go to the control area here. Well, we can look at the diagnostics. Motor change detected. We can click on acknowledge all here or acknowledge all here. So we just get rid of the faults after we just did cycle of power. So residual faults. And I want to do some movements here. So this right here, we're taking control, and we're going to enable the power stage. The safety function requested. So I've got an e-stop press right now. So reset the e-stop, acknowledge all. Now I can turn this on. Power's on. Not referenced, and go to the control thing here. I can start a homing routine, and starting the home now. It says homing over here. Homing's active. You can see the drive's moving. It's finished homing now. Drive has been referenced, and now if I want, I can set up some target positions. Let's go to, I don't know, 1000, and execute. And you see it's moving. I go a little faster. And execute again. It moves a little faster, so now it's done. And if I want to jog it, press and hold, press and hold. Anyway, that's the gist. So we know we have control over the device, and from a diagnostic standpoint, we have some other things here. Everything's all good. We can look at the I/O status here. And you know, if we want, we can do some auto tuning. I'm just going to ignore this because right now, as far as I'm concerned, we're good to go. We want to get the controls up and running between the PLC and this device, so we've got a good project to start with, and we're going to move on to the other software now. Okay, so we're going to start up some software here. Again, I said I was going to use 20.04 for the base here. I mean, 32 is out, but I like to start old. That way, any project I have is just forward compatible. Start that up. You can see it's nice and quick, like all software these days. So we have a fresh project here, and we're going to save the project. So click on New. Have to create something first. Okay, so I'm going to pick L30 ERM 20. I always call it PLC, that way it's the file name that really takes precedence. I'll give it a path. All right, I changed my name. I changed the name to this here. We're in this path. Click on OK. And it will create a project base. Okay, so there's the name of the project. I'm going to change the name of this to PLC, which is what I was trying to do before. That way up here, it's just PLC in this file name. It's very simple. And you'll see here that we have a base project. Save it. Okay, the next step is, or would be in the project itself, to add a new module here using the EDS file. So let's talk about the EDS file for a second. You go back to the support portal page here. You download the firmware package right here. The EDS files are installed, or they're occupied in the package itself. So the EDS file matches the firmware. And so let's just do a quick overview of how to install an EDS file. There's a couple different ways. You can come into here. If it's in your tool menu, click on installation. Hit the next. I always click on directory and say everything. And I already have a folder with all the files, so I'm just going to hit the enter button there, hit the next. So I've got the two files here. So I've got a CMMT, which is the AS, and then I've got the stepper, which is this one here. I would go through here, through here. It registers. The files are already there, and that's it. The EDS files are registered. Now when I come to the next step, right now it's refreshing the list in the background here. Just wait a minute. Okay, so now when I go to add a new module, which is basically adding the connection between the CMMT controller and the PLC here, the process data. So click on new module, wait. So we could go through here, we could come through here, do communication, and controller, turn that off, controller, and that's the PLC controller. You come over here and filter just through Festo, for example. Let's just turn off everything except for Festo. So everything over here, that's Festo. So I have these two right here. The alternative way of doing that is just come up to here, and then CMMT, and then we come in here, pick our controller. So we're connecting to a CMMT-AS today. So I'm just going to click on Create, and it's going to add that. There'll be a pop-up. Now we can start configuring the connection. Okay, so first thing, give the connection a name. Give the connection an IP address. The IP address, as we go back to the parameterization, the Fieldbus page. So we chose 185 here. So 192.168.1.185. That, of course, has to match in the PLC. And you have already configured it. We'll show you that after. Come down to here. The format expected at the AOI is an int. So we're going to change it from SINT to an int. We'll pick on exact match. Click on OK. Yes. Connection. Let's go with 10 millisecond. This CMMT controller is able to go down to 1 millisecond. Hit OK. And close. And we have our connection here. Now you could at this point simply go online, which we'll do. Let's configure a path here, who active. Waiting for the scan. What I'm trying to do here is pick the PLC that we're going to go online with. Hit the plus sign. I've got a couple of connections here. So these connections here I added in ours. So I'm going to say set path in the project, and I can do a download right now. So all I'm trying to do is to make sure that there is a connection, and let's see what happens. We're going into program mode temporarily, we're doing download, changing it back to run mode, and we're good. There's no errors. If you hit any errors, you would find them on the page here. No faults. Everything's good. Module info tells you that you're a match. Everything's all good. Tells you what your IP address is and whatnot. There's no gateway configured, which is fine. Port configuration, auto negotiate. There's only one connection there. I'm basically, like I said in the picture here, we're going into the top in port and then coming out of the top port and going into the X18 port. And the network where you don't have a supervisor or DLR ring set up. Okay, so we're good. So we've done that connection part. So let's go back offline and save the project. Let's just talk about RSLinx Classic for a second, or RSLinx in general. Okay, let's start RSLinx Classic here. So if you've installed RSLinx and you've never configured anything, the first thing you need to do is configure your drivers. You come through here, EthIP, you say add new, it gives you this. Come through here, you pick a port. So I've got 3 connections I can choose from. I've got a wireless and 2 hard ports on my computer. I'm not going to choose any of these because I've already got these ones here. If you look, you can configure. So this one is configured for that. This one is configured for the second one. This one's configured for the third one. So I've got all bases covered here. Wrong button I chose. So, and then when you go to RS2, you'll see here that you have whatever is connected anywhere you can see. Okay. So there's my devices, and you'll see that I have that. So whatever you have configured here shows up in the RS software here. Now, before we go further with the Logix, I'm just going to show you some Festo Field Device Tool. So if we go back to the website, we're still on the same controller here. When we scroll down to the bottom, we're looking for Festo Field Device Tool. So this right here. So we download the software. You install it like any software. Probably it's an exe file, and it shows you here that it's supporting this controller here. And I'm just going to quickly open that up. So Festo Field Device Tool, I have this in my desktop here. We'll start up the Festo Field Device Tool. The Festo Field Device Tool will scan the network for any Ethernet devices. Of course, it's on the wrong screen. So it's going to go through here. It's going to find a variety of devices. And when it's finished, we can click on each device. So this one right here, the 1.184, that is the X18 port. Again, the X18 port on the front. And then we have the 185, which is the X19 port on the top. And this shows you here that version 17.0.8.48 is the software that's been installed. If that firmware was not the right firmware and you want to update it, you can click on firmware. We can go through here and pick a firmware, and then we would proceed to download and so on and so forth. Okay, and then you would say download. I'm not going to do that. It's showing you what options we have here. Let it rescan. Other options, network. So this is where you come in here and you would modify the IP address for that port, modify the IP address of the EthIP port, but keep in mind that the project in the Festo Automation Suite controller will overwrite that value. So it'd be best just to come into here and modify it here. So Festo Field Device Tool, we're gonna close that now. This is just another tool for diagnostics. And the best thing you can do is that firmware download. If we go to the Festo Automation Suite project here, there's a scan tool as well, device scan, and it will find the same devices here. So the 184, 185, and you can come down to here, see everything about the controller, modify the network settings of that particular port there. You don't want to do that for the IP because it's in the project, it will get overwritten. The firmware, you can do a download from the internet automatically. You would just click on that and say transfer device, and it would download that to the computer and then download to the device. And we can also add this whatever is online to the project, but we're overwriting everything right now. So go back here. Again, over here, if I go back offline, disconnect. I'm just showing you a variety of ways to do everything here. So you can also click on this device. You can also right-click and say change network settings. And you can modify this IP address right here. So there's many different ways to get to the same result. The software offers flexibility. So now let's get back to adding the EDS file. So the EDS file has been added. We've added the controller to the project for the process data, and now we're going to move on to the add-on instruction. We go back to the website. Go to the very top here. Function blocks Rockwell. I don't know why they call them function blocks or add-on instructions. Function block is a Siemens term or other programs, but anyway, the function blocks, you would download this. And you would download that. I've already downloaded it right there, which is over here. You open that zip file up. So here's the here's the zip file right here. I'm going to open it up just to show you what's in it. So there's a documentation directory, and there's an application note on how to do this. There's a EPD manual, which is extended process data. This one here is the point-to-point, which is what PTP stands for. And if you open this file up, it gives you a full manual on what I'm doing here. And you just start scrolling through, it takes you step by step. And the AOI's directory, we have the AOI we're discussing right now. And it has the extended process data, which is the EPD one. I'm not going to talk about that in this particular one here. And then we have an examples directory. The documentation, this one right here, discusses this file right here. But additionally, there's other PLC examples here. So this one here, you'll see here v32_11. So that's programmed in version 32. What do they call these days? It's not RS 5000 anymore. It's LogixDesign 5000, I think now. And this is version 32.11. These projects right here are done in the oldest. So EDS file started support by Rockwell in version 20, and version 20.04 is the oldest supported version of Rockwell on Windows 10. So I picked the oldest for Windows 10 and for support for EDS files, and that's why I did the sample code here for that. And the L30 ERM, that's ControlLogix, and then the L61 is a ControlLogix program. The point-to-point library is version 1.2. The EDS in the name stands for Electronic Data Sheet. GEN stands for generic, so there's no EDS being used. And then the moves no, moves yes. Moves no just means that it's just an AOI. You can just play with it and do what you like. And then the moves yes, there's some sample code on how to move some axes around using the point-to-point AOI. So that discusses the thing here. So let's get back to our PLC project here, and let's add our add-on instruction, or import it, sorry. So we're going to right-click, import add-on instruction. Okay, and I know the directory, so I've just copied the directory. I'm just going to copy and then enter. So that's going to take me to the directory. This is the file right here. So this is the file we're going to import right here. Click on import. In this case here, we're going to accept all the defaults and just click on create, which is up here, and hit OK. It imports, and over here on the left, we'll see that it imported the add-on structure and then added some data types. So there's here are the help files here. You can see, we expand this here a little bit, shows you about the AOI, different fields, gives you some parameters and what they mean, meaning behind them, and extended description gives you the version information. There's the release date, any changes if there are any, and there's that, and then there's a couple of data types down here. So we've now added or imported the add-on instruction. Next step is to deal with the task. So in the Rockwell controller, we've got some fundamentals just in case somebody doesn't understand what things are about here. So we've got more or less two different tag areas. We've got controller tags, which are global scope tags. And then we have programs, and then within the programs we have routines. Each program has a program tags area, so those program tags are only visible to the routines in that program. Pretty standard stuff when it comes to programming. Controller tags, this is where you'll find what we just added there. So this right here, connection, automatically generated these tags. Okay? No, this is not the best view. I don't like the gray. I don't know how to change it. It's because it's the older software. It's much better than the newer software. But basically, this connection here, which was a size of 12 ints in and out, 12 integers right here, shows you that there's 12 ints right here, in and out. And there's always a connection faulted. These are the two important ones right here, which we'll use in a minute. So the main routine here, this main task here is a cyclical task. It's continuous. There's a watchdog on it. And the program, we only have this one program schedule. You can monitor this when we're online. So basically, moving forward from here, we need a couple of things. I always use the main routine for calls to other routines. You can organize your program that way. And then we have the ability to add routines here. So I can add a new routine if I want to. Okay, so I'm going to paste in a routine that I've already created. Okay. And I have errors right here on the left. That's what this means. And then in the controller tags, I'm going to paste in some tags. And the idea here is that we want to get a status. I always add the status to my code because a lot of times you end up using a generic Ethernet module, and the generic module does not have this connection faulted bit. So the fact that the connection faulted bit exists in this particular project, we don't need this code, but I like to have it in here anyway. That way if I need to use it, it's there. And the idea is that I'm looking for a module. Just like here, you add a new module. This is a module. And we want to find the instance name. The instance name is the name that we've given it right here. This is the instance name. And I'm getting the attribute fault code, storing that in the device status. And if there's any fault at any point in time, connection lost, like cable missing or whatever, then device status not equal to 0 anymore, and therefore I have a faulted. And you'll see in the AOI later on that we need a fault status added to the AOI in order to allow proper integration and function of that AOI. So next step here is to add a jump subroutine. So you can go through all these statements up above here, all these instructions, or if you double click and you know what you're talking about, just type in something, jump subroutine, and then jump subroutine is going to be jump to that one. And now we are already scanning this because I showed you in the main task, and now the main routine is coming out and scanning this particular routine here. And the next step is to add a routine specifically for the AOI. That way we have some structure to our program here. So click, right click, new routine, give it a name, ladder program. I could do structured text or something else, but I'm using ladder here. I'm going to say open routine right away, click on OK, and it's added that and it's now here. So now we need to get this AOI onto the spreadsheet here, or onto the routine. And how do we do that? So there's a couple ways, just like there is with any program. So there's click down here, click on add-on, and this point-to-point drive is right here. So I could click it and add it, or I could come over here and simply click and drag, drop it, and we've added it. Okay. Okay, the next step is to instantiate or create an instance for this add-on instruction. So many times you'll have many of these same blocks used, and you have one of these per controller here, and you basically start by adding a name. Let's make this text a little bit bigger for you guys. So double click. I'm going to call the axis X function block, and I could go up to controller tags, do the same thing, come down here and do it of the type point to point, so point to point, and by doing that I've given it that name here. Alternative way is, see how it's undefined here? You've added it and you're right here at the thing, at the AOI, you right click, type in new axis FB. You have to pick the scope, so we're picking the PLC scope, so that's the controller scope. I want it to be visible to other programs, and it'll pick the data type automatically for you and just say create. And if you go back to controller tags, it's done the same thing we did manually. Just a couple different ways of doing things. The next configuration part, if you don't see what I'm doing here, I'm going back and forth by Control Tab, Control Tab, Control Tab. These are the open windows. Okay, so drive status, drive control. So we need to map the real process data from the CMMT, which is from this connection right here, to the AOI. And we could come into here, we could pick, go into here, click on that, double click. That's been added. Or we could go back to the controller tags, click on this, copy, go back, paste, and then we get down to the connection faulted. So like I said, I can use this device faulted bit, or I can go right back to the input table there, the connection faulted. So there's that. Or you can do the copy paste. And now the AOI has been configured. It's pretty much simple. Or it's at least set up to the point now where we could download and start to play. I'm going to add a couple of things myself here. So the mode, there is a user manual for this AOI here, and the user manual itself will show you, well, let's just quickly open it. So I went back to the zip file, I opened up the application note underscore point to point drives underscore Rockwell, and I'm in section 4 here, and you'll see here that there is, let's just widen this a little bit here, there's a section IO interface area tag details. It gives you a overview of what each of the things mean here. So for example, mode position, this is the most important part of the block as far as I'm concerned, because it puts you into different modes, you know, 1 relative, 2 absolute. There's a home using the Festo Automation Suite config, or home to the current position. There's record select, there's jogging, and there's inching. So the user manual here will describe all these tags right here. I'll just give you a brief overview on how to operate everything. And the first thing I want to do here, Control D, paste, and I've added the ModePos meaning, which is like I just showed you there, which is right here. This right here. This is me giving a little more information here, just so that it's in the code, I can actually see it. The next most important part of this block here is the ConfigEPos. Okay. The ConfigEPos, if you go through the manuals, is a configuration of individual bits. I'm going to add a rung using the instance right here, right above it. So I'm going to add rung, and I'm going to drag that to the top. Okay, and I'm going to add a bunch of bits. Okay, so I added all the bits. I simply went over here, to favorites, added this, take this right here, this name right here, Control Copy, Control C, and then do a dot, and you'll see that you do a drop down, and you go down to the ConfigEPos, and then pick a bit. That's what we just have right here. And then these bits are already labeled in the code through the AOI instruction, and the user Festo did all that for us. And we'll see here that, you know, off 2, off 3, what they mean. The software limits enabled, 3 is hardware limits enabled. So the fact that it says ConfigEPos, it's configuration bits for the positioning task. Okay. The next thing here is, if you go down to AOI again, you'll see here that you've got 2 these words here, EPOS LSW 1 and 2. Again, those are described in the user manual. I'm going to add those bits individually. I've already got a couple things I prepared here. Again, the instance, then the EPOS LSW1, and then the bit. And they're already labeled here and gives you an idea what they are. So now I've got an overview of what everyone looks like, and I can see everything relatively easy. And the last thing before going online is just bring this back to view here. We have this base value speed. So this base value speed must match that of the configuration in Automation Suite. Otherwise, the actual velocity down here will not show up properly. So base value speed is on the Fieldbus tab here. The base value velocity is 0.5. All right, the last thing here is we have this base value speed, okay? This base value speed needs to match what is configured in the Festo Automation Suite project. So if I go to the Festo Automation Suite project, you'll see here that I have 0.5 meters per second. In the PLC here, that would be represented as 500. If I can type. If this does not match, that means that the actual velocity feedback coming back will not be what you're looking for. It'll be a mismatch. It won't represent the proper value. There's some calculations done in the AOI to accommodate for some things in the drive there. That's all. So that's the last thing. And now we're ready to download to the controller. So we come up here, download, because we've already previously done the project setup, project path. Do a download. And we're good. So we've got access ref, we've been homed, we have an error. So from the standpoint of this here, we've got diagnostics, Profinet communication failed, that'll be EtherNet. Basically, we've got some faults. So what we do here is we come into the acknowledge error, throw 1 out there. That just reset the error. No errors. And we read the manuals here. There's a default of immediate stop. This cancel traversing, you also need to be a 1. So both the cancel and immediate stop both have to be high. And then at this point, we can turn this on and enable the access. Then the access is enabled. Over here, power on, drivers referenced. We're all good. And now we can start to play. So Let's just try our move here. We're at position 1994932. There's the scaling -6. This is in meters, so we're scaling it down to millimeters, and we get the conversion, which ends up being a whole value there. And we want to go, let's just go to 0. So execute mode, hit 1, acknowledge set point. We're working, but we're not really moving. Well, that's because we don't have a velocity. So can't type here. Rising edge. So now we're moving here, and those are not values. This is percentages. So I'm going to put these back. And we're at position 0. So if I increase the velocity and change this so we're not matching, let's change it to 250, which is half. We're demanding 200, so instead of it coming back as 100, it should come back, or instead of it coming back as 200, it should come back as 100. So let's do that typo here. Let's go to 1995. Execute mode. See, you're at velocity of 99 because we didn't do it right. We put this in. Now we're at 200 velocity, which is correct. And that's it. We're there. And we can change to relative mode, so I can put 1 in here and put a minus in here, and it just moved minus 100 millimeters. You can see that over here. So we're at actuals 1895. This off and on again. And we're at 1795. And 1795. So there's your relative moves. 4 is, change to 4. It's actually homing right now, so it just executed I had the execute mode on, so it executed the routine immediately instead of waiting for my execute mode. So typically you would have this, you would be in this mode right here, and then you would change to mode 4. You did not execute anything until you execute this. Now it's executing the move. And if you drop at any point, it'll not home. So it's still homing there. Let it finish. You see the axis ref comes on. Okay, so I'm going to turn that off. So that was 4. And if I go back to 2 for a second here, just to get away from that point. I caused a fault because I didn't do something right. Reset the fault. Reset the enable. I'm back enabled. Execute mode. It's now executed. We're off execute mode. And now the I'm going to execute number 5 here. So mode 5. And execute. Notice the position down here, and we just home to 0. Go back to mode 2, execute, back at 100,000, and we're in mode 2. There's a flying reference. So if I press 1 right here, it's going to execute. And it's doing the Festo Automation Suite homing routine right now. So it's on the fly reference by the 1 bit there. And it's homed again. Turn it back off. Let's go for jog mode. So 7. I want to jog forward. And 1 here. It's moving forward. Jog minus. And those right there are executing these values right here. You go into the parameter list. You search for jog. You'll see here that there's a little more information. There's jog 1, and you have velocity, accel, jerk, full setup, and then jog 2. So you have these values right here, okay? And you can turn off symmetrical if you don't like that. There's also this relative jog. And relative jog 2. So this right here is this value, this increment size. It's what's used in mode 8, which is the incremental jogging. So I'm not going to do that, but that's the gist of how this works. This right here, you'll see that the software limits and hardware limits have to be enabled through here. If they're not enabled through here, then whatever you have in the Festo Automation Suite program will be overwritten. And so we have established communications, installed DDS files, added the imported the add-on instruction, and added some small tidbits of code, all within a whole hour. And that's not too bad to commission a servo axis. Okay, I hope everyone enjoys this. Have a great day.